All right, today we're going to get into something pretty wild. We're talking about finding leaks so incredibly tiny, they are almost impossible to even imagine. This is all about the science of finding the unfindable. So let's just dive right in.
So let me just ask you something. How in the world would you find a hole in a massive piece of industrial equipment, we're talking pipelines, pressure vessels, that is literally smaller than one single bacterium? It's kind of mind-bending when you think about it, right? I mean, the absolute tiniest flaw can lead to a huge failure, but finding it feels like an impossible task.
Well, believe it or not, there is an answer, and it operates at a sensitivity that is just almost unbelievable. Just look at this number. This is the target we're shooting for. It's a leak rate of 1/trillionth of a millibar liter per second. I mean, come on, that's a number so small it's really hard to even wrap your head around it.
Okay, so to put that into perspective for you, a leak this small is so ridiculously slow it would take, get this, over 30,000 years to fill just one soda can. That's the scale we are dealing with today, finding leaks that are, for all practical purposes, completely invisible and moving at an impossibly slow rate.
So you might be asking, why go to all this trouble? Well, it's because in these really high-stakes places, like oil rigs, gas plants, cryogenic facilities, these invisible little microleaks are a huge threat. They can compromise safety, they can damage the environment, and they can cause shutdowns that cost an absolute fortune. And this right here, this chart really shows you what a massive leap in technology we're talking about. For years, the classic method was the soap bubble test. Yep, literally just looking for bubbles. And sure, it works for big leaks, but look at that comparison. It is millions, no, billions of times less sensitive than helium mass spectrometry. It's not even in the same league. It's not even the same sport. And that brings us to our hero of the story. See, to find a leak this small, you don't just need a tool, you need the perfect detective. And in the world of industrial testing, that detective is helium. It has this very unique set of skills that makes it just perfectly suited for this kind of microscopic investigation.
So let's take a look at its resume. First off, helium atoms are just incredibly small, so they can squeeze through cracks that other, bigger molecules just can't. Second, it's a noble gas, which means it's totally inert. It's not going to react with anything or cause any damage. Third, it's super rare in the air around us, so when a detector picks it up, you can be pretty darn sure you found your leak. And, last but not least, it moves fast, which lets you pinpoint the exact source of the leak and do it quickly.
So, how does our little detective actually conduct its investigation? Well, there are two main strategies, and which one you use really depends on the crime scene. You can either force the helium out of the system, or you can pull it in. This slide breaks down the two approaches perfectly. Over on the left, you've got the outside-in method, also called the vacuum method. This one is the most sensitive. You create a vacuum inside the part, then you spray helium all over the outside. If there's a leak, whoosh, the helium gets sucked right in. Then on the right, you've got the inside-out method. This is for things you can't put a vacuum on, like a really long pipeline. You fill it with pressurized helium and then use a sniffer to find where it's trying to escape.
Okay, so let's walk through that outside-in method. First, you pull a really strong vacuum inside the system. Then, a technician goes around and carefully sprays helium gas on all the places a leak might be hiding, like welds and joints. If there is even the tiniest path, the vacuum sucks those helium atoms inside, where a detector is just waiting to sound the alarm.
Now, the inside-out method, it basically flips the whole script. First, you pressurize the system with a mix of helium and nitrogen. Then, you crank up the pressure, which forces those tiny helium atoms out of any little escape route they can find. A technician then takes a handheld sniffer and scans the whole exterior. The second that probe detects any escaping helium, boom, you've pinpointed the leak.
Of course, none of this detective work would be possible without some seriously advanced tools. This isn't just a can of helium and a good ear, We're talking about a whole suite of high-tech forensic equipment. And the heart of this whole operation is the Mass Spectrometer Leak Detector, or MSLD. The best way to think of it is as a super sophisticated electronic nose, one that's been tuned to smell only one thing in the entire world: helium. It can literally pick out a single helium atom from billions of other molecules in the air. It's just incredible.
And the rest of the toolkit is just as impressive. These systems respond in less than a second. They're constantly calibrating themselves to make sure they're accurate. The sniffer probes are even heated, so you don't get any false readings. And maybe best of all, everything is logged. It creates a detailed map and a report of every single leak, where it is and how bad it is.
So we've seen the threat, we've met the detective, and we've checked out the toolkit. But what does this all really add up to? I mean, the goal isn't just about finding leaks, right? It's about building a safer, more reliable, and just plain more efficient future for all of us.
And here's the payoff. This is why it all matters so much. Finding these tiny leaks makes things safer because you prevent failures before they can happen. It protects the environment by stopping stuff from getting out. It makes systems more reliable because you get rid of those expensive, unplanned shutdowns. For really sensitive stuff, it guarantees purity. And finally, it gives you certified proof that your system is solid, secure, and ready to go.
You know, when you boil it all down, it really comes back to this one powerful idea. This isn't just routine maintenance. This is a proactive strategy for preventing disaster. It's all about making sure that our most critical infrastructure works perfectly, right from day one.
It's a pretty powerful reminder that some of the most important technologies working for us are the ones we can't even see. And that kind of leaves me with a final thought for you to chew on. What other invisible technologies are out there working behind the scenes every single day just to keep our world safe and running? It's pretty cool to think about. Thanks for tuning in.